Good afternoon, you wonderful person. Today we're going to be talking about scaling a figure relative to a center of dilation or compared to a center of dilation. Okay, so let me read this first. Scale the figure by a scale factor of 2 relative to the center of dilation. So here, this word scale is a verb that means to make bigger or smaller. And so we're going to be scaling the figure. Figure means the picture by a scale factor of 2. Scale factor tells us when you go from the original to the dilated figure, how much is it going to change? Here, everything's going to change by times 2. Okay, and we're going to make it 2 times bigger relative to the center of dilation P. Relative means compared to. Okay, so compared to this dot right here, we're going to make this picture 2 times as big. So how do we scale a figure relative to a point? Well, so what we do is basically we're going to pick points on this triangle, and then we're going to scale those points compared to this point P. So I'm going to pick the 3 vertices of the triangle and compared this vertex right here to this point P. It is 3 centimeters big. So this line right here is going to get scaled by times 2. It's going to get scaled by a scale factor of times 2. So if we were to change this line times 2, it would go to 6. So this line right here in red gets scaled all the way over to this point right here. So that if this had been point A, this point right up here is now A prime. Okay, and let's do that with the other points as well. So let's say that here we have, I'm going to turn this upside down. Here we have point P relative to, let's say, this point right here. It is about 2.2. This distance from here to here is about 2.2. So we're going to scale it to 4.4. So if this was point B, this point right here is now B prime. And let's do it over here as well. So let's do that point compared to there. This point right here is about 6 big, or the length is 6. So we scale it to 12, or 2 times the distance. So this point C was scaled all the way over to here at C prime. So now if we were to just connect those 3 dots right there, I just realized this looks wrong right here. Let me fix that. Set a length of 2. Okay, so that looks about 2 times as big as that was. Okay, so now if we were to connect A prime, B prime, C prime, it should look like the other figure, but 2 times bigger. Okay. So there we go. The blue triangle A prime, B prime, C prime is 2 times as big as triangle ABC relative to this point P. Okay. So this is how you just do it on a nice blank sheet of paper, scaling a figure when there's a center of dilation. Let's do this now on a grid. Okay. And here you can pick anywhere on this grid to be your center of dilation. For right now, I'm going to say let's pick the center of dilation P to be 0, 0. So we're going to pick this point right here to be your P at 0, 0. And let's dilate this, let's dilate or scale this triangle by a scale factor of 3 with this as the center of dilation. So once again, we're going to change the distance from this point P to points on the triangle by times 3 or by the scale factor. Okay, so let's say this point right here, I'm going to measure the distance from here to here. Okay, so I'm going to measure that distance, and then I'm going to multiply it by times 3. So if I take this distance right here, oh, sorry, I just realized that I'm off the paper. So if I take that distance right there, and I were to multiply that distance by times 3, it would end up being this long. Okay. And if I were to take this distance from here to here, okay, if I was going to take this distance from here to here, and if I was going to multiply that distance by times 3, it would be this long. And last one. Let's take this distance from here to here. I measure it. So if I took this distance, I looked at what number it was, and then I were to multiply it times 3, it goes this far. Okay, so this distance right here times 3, 1, 2, 3, ends up right there. This distance times 3, 1, 2, 3, ends up right there, etc. Okay, so then I just have to connect these new points. And I should have a triangle that is 3 times as big, and the distance from the points to the center of dilation to point P should be 3 times as far. So just for record, this way of dilating is actually how movie theaters work. They have a small projector in the back, and it dilates a small picture in front of the projector to become a big picture on the screen that you actually watch. Okay, so this is dilating a figure by a scale factor relative to a center of dilation graphically. So here, if you notice, all I've done is use a ruler and measure distances, and I dilate it that way. If the center of dilation is at 0, 0, you can also very easily dilate this figure using math, using algebra. The way we could do that is if we were to go over here and we were to look at what the coordinates are. So the coordinates for this right here, this is 3, 2. And if you were to dilate this point by a scale factor of 3, then you could just multiply these coordinates by times 3. So 3, 2 times 3. 3 times 3 is 9. 2 times 3 is 6. And so if you notice, this point right here, this is at 9, 6. So here, this point right here is 9, 6. Okay, and the same thing with the rest of them. This point right here is 4, 5. Times 3, that would be 12, 15. 12, 15. This point right here, 8, 3. So 8 times 3, 24. 3 times 3, 9. So over here, 9, 24, 9. Okay, so this only works if your center of dilation is 0, 0. At least in this simple, you can just multiply it by the scale factor. If the center of dilation is not here, you have to do a little bit more math to figure out where the new points are. Okay, if you have your center of dilation at 0, 0 here, let me show you what happened when you have a scale factor that is negative. So let's go to this figure right here. And let's say that I'm going to scale this figure. Let's say that I'm going to scale the figure by a scale factor of -1. With a center of dilation at the origin. And just for record, this word origin just means 0, 0. So, okay, so this here is our center of dilation. And I want to scale this by a scale factor of -1. Then all I'm going to do is multiply the coordinates by our scale factor. So this right here is 3, 1, right here. So if I multiply that by -1, that would become -3, -1. And over here, this is 2, 4, 6, 8, 10. So this is 10, 1. So our new, when I scale it by times -1, it would become -10, -1. 2, 4, 6, 8, 10, -1. So right there, that is -10, -1. Last one over here. This is 3, 2, 4, 5. 3 comma 5. So -3 comma -2 4 5. Okay, so there you go. Right there, that is us scaling a figure by a negative scale factor. And so if you notice, not only so you have this figure. So not only is the quadrant that the figure is in changing, it kind of looks like this figure was turned 90, this figure was turned 180 degrees to make this figure. So if I like get this paper and I sort of were to turn the paper by 180 degrees, it still sort of looks the same. So that's what happens when we scale by -1. All right. I hope that made sense. I hope you guys have a great rest of your day.